Good evening to all. Today topic is carbanion and its stability. Carbanion. So carbanion is the anion of carbon. Simply you can call that the carbon anion. Here the carbon anion contains three bond pair of electrons and one lone pair of electrons. One lone pair of electrons. Then it has the hybridization is sp3 hybridization. sp3 hybridization. This has the 8 electrons in valence orbit. If any atom or molecule having 8 electrons in the valence orbit, then it obeys the octet configuration. Obeys octet configuration. These 8 electrons are paired. There is no unpaired electron. There is no unpaired electrons. Hence, it is a diamagnetic in nature. Hence, it is a diamagnetic. It is a diamagnetic in nature. Then, it is a charged electrophile. It is a charged nucleophile. It is a charged nucleophile. It can reacts with electrophile. The geometry of the molecule is pyramidal geometry. Geometry of carbon anion. Pyramidal structure. We know very well if any molecule having the sp3 hybridization and 3 bond pair of electrons, 1 lone pair, then it is considered as the pyramidal geometry. Here it has the negative charge and 3 bond pair of electrons. Then this structure is known as the pyramidal geometry. So right, this is about the introduction about the carbon anion. Now we are going to discuss about the stability of carbon anion. Stability of carbon anion. The stability of carbon anion can be depending on the following factors. First one is the electronegativity. First one is electronegativity of carbon anion. En of carbon anionic carbon. Carbon anionic carbon. The stability of is directly proportional to the electronegativity of carbon anionic carbon. So here the electronegativity of carbon anion can be depending on the it is electronegativity of carbon anion can be depending on the is directly proportional to percentage of S character S character. Since from these two equations we can conclude that the stability of carbon anion is directly proportional to percentage of S character. Suppose we have to take some example. The first one is CH3 single bond CH2 minus. It is one of the carbon anion. Then one more thing, you have to take CH double bond CH minus. Then one more CH triple bond C minus. So here in the case, in this case, the carbon having the hybridization is sp3 hybridization. Here, this carbon having the hybridization is sp2 hybridization. Then here this carbon having the hybridization. sp hybridization. So before we said the carbon anion contains only that sp3 hybridization. Generally you can said, but based on the bonds present between the two carbon atoms, we can decide the hybridization. Here this carbon anion contains sp3 hybridization. This then here in the part here in the case the percentage of S character is here is equal to, so 25% S character will be present. Here how much S character? S character is equal to 33.33% will be present. Here S character is equal to 50% will be present. So according to we said the electronegativity, how more electronegativity element is that one is the third one. This is I am going to give the numbering. For this one is numbering 1. This is numbering 2. Here the numbering is 3. So based on the above point, the stability is order. Stability order is third one is greater than second one. Second one is greater than first one. Because the electronegativity is more here, because the percentage of character is more. If the S percentage is more means then it can increase the electronegativity. So if electronegativity will be more means more is the stability. Next one we are going to discuss about the second factor is the inductive effect. The second point is inductive effect. So we know very well the inductive effect contains two type of groups. So the first one is the plus I power groups or plus I power groups, and another one is the minus I power group or I groups. So here in that case, the stability of the carbanion can be depend on the magnitude of charge. So we know very well the stability is inversely proportional to the magnitude of charge on the ion. Magnitude of charge. If more is the magnitude of charge, it will be less stable. So that is the reason the carbon anion stability The carbanion stability is inversely proportional to plus I group plus I power groups, because if the number of plus I groups can increases, more electron density will increases on the carbanion. Hence, the result, the magnitude of charge is increases, then the stability can decreases. See here, we are going to the example is here methyl carbanion, and next one is ethyl carbanion, and next one is propyl carbanion. Till other secondary here. Next one is the tertiary carbon anion. Tertiary carbon anion. Here the electron density. Here one electron releasing group will be present. Then this can donate the electrons to this CH minus. This one here two electron donating groups are present, then they can both are donating. Here electron density is more. Then again here three are there, then they can increase the electron density on this carbon. So hence here what happening, the charge density is more for the tertiary carbon anion, then the stability will decreases. So the stability order is stability order, we are going to write here the methyl carbon anion is more than primary carbon anion. It is more than the tertiary secondary, and secondary has more carbon anion stability than tertiary carbon anion. So this is about the, when we can conclude that when the more is the number of plus I groups, the stability can decreases. Stability can decreases. So you have to remember this point is most important. So as we know earlier about a inductive effect, if more is the magnitude of charge, there is positive charge or negative charge, stability can decreases. So in that carbon anion stability can decrease plus more number of electron releasing groups. The next one is if the minus I groups increases, carbon anion stability is directly proportional to the minus I power groups. Minus I power groups. So how it is happening, see here. Suppose you are taking the example, the minus I power groups. Example you have to take halogens, that is fluorine, chlorine, bromine, iodine. Here the order of minus power is more for the fluorine, next chlorine, bromine and iodine. So here in the case you are taking the stability, suppose you are taking going to take the example CH3 minus CH2 F. Here next one is CH2 minus chlorine. Then here you are taking the CH2 Br. Then here CH2 iodine. So the minus I power is more for the fluorine atom. Then it is ready to accept the electron from the carbon. So more electrons can shift towards fluorine. So here because the fluorine is the electron withdrawing group. Fluorine is the electron withdrawing group. Here already minus charge, it is attracting means then the charge can be decreases. Here also then So based on these all are the halogens, everyone is only every is a electron withdrawing, but the order is more for the fluorine. So the carbanion stability is more for the fluorine containing the molecule. Then the stability order of carbon anion is, suppose I am going to give the numbering 1, 2, 3, 4. So here that stability order of carbon and 1 is greater than 2, 2 is greater than 3, 3 is greater than 4. So what is the reason here? Because of the minus I power of the group, minus I power of the group. Then you have to remember this one, this is the most important. So generally they can ask directly, otherwise they can ask indirectly, they can give some compounds, then they can ask the based on that stability how it will be affected by the inductive effect. Next one is allyl and benzyl carbon anion. Allyl and benzyl carbon anion. These allyl and benzyl carbon anions can be explained by the resonance effect. Can be explained by the resonance effect. How it will the stability of carbon anions can be explained? Resonance effect. Resonance. So we know the number of resonance structures increases, stability also will increases. Number of resonating structures, resonating structures increases, stability also will increases. Stability will increases. See, suppose we are going to take the example that allyl carbon anion. So we know what is the structure of allyl. So they have the double bond, and next one is the single bond. Then this type of compounds is known as the allyl. Then here negative charge it is the allyl carbon anion. Suppose this allyl carbon have one more resonating structure. How it will be formed? This the negative charge means the a lone pair of electron can be shifted to this here. Then this bond can migrate to this carbon atom. Then we can get a CH2 minus single bond CH double bond CH2. Then how many resonating structures are possible? Resonance structures equal to here 2. Now I am going to take a benzyl carbocation. Benzyl carbocation. See here, so alternated double bonds will be present in the benzene ring, and here the CH2 group and have the negative charge. Then this is known as the benzyl carbon anion. So here if the benzyl carbon anion have four resonating structures, this negative charge can be migrated to here. Then this double bond can automatically shift to this carbon. Then it will get a like a structure here. See, double bond, then here double bond CH2. Because the carbon have four valence, it has to satisfied. Then here, so nothing but here what happening? The negative charge is involved in the delocalization. Because of that delocalization, they can form a resonating structures. Then more is the number of resonating structures, then they have more stability. Then again this can be shifted to here, this carbon, then this double bond can be migrated to here. Then what is the structure it will be formed? Here double bond will be formed. Here negative charge will be formed. Then here double bond will be formed. Here double bond. So these are four cases. What happening? The negative charge can be involved in the delocalization process. The negative charge can be involved in delocalization process. So that's why. So actually, many of you are thinking that why not we can shift. Then this one and this one will get both the structures. That's why it is the final one only. Then here, what is the reason? The negative charge involved in delocalization. Delocalization. That's why then this one contain benzyl carbon anion have the four resonating structures. So with increase the negative charge involved in the delocalization process. Similarly, here next one more can diphenyl carbon anion have the seven resonating structures. Diphenyl carbon anion. Wait, I am changing the color. Here, next one is diphenyl C6H5 CH minus C6H5. So this one contains how many resonating structures? Seven resonating structures are possible for this one. Then now we are going to take the three, nothing but triphenyl carbon anion. Then it can form a 10 resonating structures. From these, all the concept, then what you have to understand. So already we are discussed more the number of resonating structures, stability also will be increases. Now I am going to give the numbering for these questions. So now we have to take that allyl carbon anion, allyl carbon anion are less stable than benzyl carbon anion, benzyl carbon anion. Then it one is less stable than the diphenyl carbon anion. Then it is less stable than the triphenyl carbon anion. Triphenyl carbon anion. Right. So this is about what is the reason, because only the concept is the negative charge can be involved in the delocalization, then more number of resonance structures can be possible. If more is the number of resonating structures, more is the stability. So this is the order. Next one is the if any, the fourth one is if any S and P, nothing but sulfur and phosphorus. Sulfur and phosphorus atoms are attached to these two atoms are attached to carbon anion. Attached to carbon anion. So that groups are more stable. So that type of groups are more stable, because here P5 D5 bond formation will be takes place, because the empty p orbitals of empty p orbitals of empty p orbitals of carbon and empty d orbitals, nothing but here empty p orbital means one lone pair actually. This so lone pair. See here it is a lone pair and empty d orbitals of empty d orbitals of phosphorus or sulfur atoms. Then they can form a P5 D5 bond. P5 D5 bond then can overlap with the laterally or parallelly. Then they can form a P5 D5 bond. P5 D5 bonding. Then it is known as the P5 D5 bonding. Suppose I am going to take one example here. CH3 CH CH3 minus, then one more case CH3 CH minus, here phosphorus C6 H by thrice. So in these two cases, which one is the most stable? Can you expect? The second one is most stable than the first one, because here P5 D5 bond formation will be takes place. P5 D5 bond formation can takes place. So see here, in this case, P5, sorry, here P5 D5 bond formation can takes place. P5 D5 bond, then it is the most stable. So the stability order equal to stability order of carbon anion. Second one is more than the first one. We can comparing, right? So this is about the one of the based on the delocalization of a negative charge. The now last one is the aromatic carbon anions. Aromatic carbon anions. So as we know very well, on that case, so anyway you have to take the aromatic compounds are most stable either in the carbon anion or carbocation. Aromatic carbon anions. Carbon anions. Right here, if more the aromatic carbon having the carbon half aromatic system having negative charge, aromatic system having negative charge, then it is known as the aromatic carbon anion, can call that the aromatic carbon anion. Suppose you have to take the example, the cyclopentadienyl carbon anion. Next one is the cyclopropyl carbon anion. So here in this case, it is not a aromatic, but it is a aromatic. The first one is the aromatic in nature. The second one is anti-aromatic. So we know aromatic compounds always stable than anti-aromatic. Anti-aromatic. Before going to that anti-aromatics, we have to take them the order of the so aromatic and next one is the non-aromatic and the final one is anti-aromatic. Anti-aromatic. This is the order when they are given the rings. then you have to verify that they are following the Hokel rule or not. Then you can say, is it aromatic or non-aromatic or anti-aromatic? So the stability order is aromatic is more than the non-aromatic. Non-aromatic have more than the anti-aromatic. So this is about the aromatic. So now we can say the benzyl they can give, then one is the aromatic we can give. So which one is the most stable, can you say? So the aromatic compounds always the most stable than benzyl carbene anion. Suppose I am giving the here. So here the negative charge cannot part in the ring, but here involved in the delocalization, but not a. So in that case, what happened? Which one is the most stable? Which one is the more aromatic nature? Then it is taken as the more stability. So this is about the stability order. So one miscellaneous compound will be there. The electron withdrawing groups will be present like a ketone. The last point, electron withdrawing. This is the ketone group and nitrogen group. Next one is the CN groups. They will be involved. Then the negative charge can be more on the more electron advantage, then only it will be more stable. Suppose I am taking for this one, I am taking the example CH3 C double bond O CH3 I am going to take. Suppose I am going to write for this one, sorry, minus charge here. Then I am going to take here the negative charge can be here the bond formation can be, then this negative charge can be formed on the oxygen. So what will be happen? The result CH3 CO minus and here double bond CH2, right? So which one is the most stable here? Do you know? Because here the electronegative, the charge here, the negative charge can be present on the carbon. Here the negative charge can be present on the oxygen. In the case of the electronegativity order is carbon is less than the oxygen. If the negative charge can be present on the more electronegative atom, then it will be more stable. It is more stable because the negative charge can be present on the more electronegative atom. What is the reason? Since because what is the reason? Negative charge where it is present on more electronegative atom, more electronegative atom. So that is the reason it is the most stable or more stable, then it is a less stable. So simply you can take an as the it is the keto form, it is a enol form. In keto enol, so the keto form is less stable than the enol form because more electronegativity element having the negative charge, right? So this is the topic we are completed. So thank you to all. So you have to subscribe my channel. So right, thank you channel.